Hello, and welcome to today's online panel discussion on the topic of handheld laser safety and closing welding knowledge gaps. My name is Mark Elliott. I'm the COO of Europa Science, which is the publisher of Electro-Optics. We are going to spend the next hour or so exploring how to ensure complete safety when using handheld lasers and how to overcome those knowledge gaps that may be present across welding applications. Of course, as laser safety companies continue to develop and evolve their products, end users must properly navigate the market to find the right tools for their needs and applications. And of course, as increased guidance around risks with handheld lasers and how to mitigate them remains in high demand, the challenge of how to bring this knowledge in-house to end users remains considerable. The online panel discussion will explore the barriers and knowledge gaps that welders currently face, what to consider when ensuring safe application of handheld lasers, and how to put the evolving laser safety market to best use possible. We'll also focus on that perennial question, what's coming next? No pressure then on our expert panel, which is of course a nice segue into offering them a welcome. First, a good friend to this series, I'd like to say hello to David Lawton, who is the Market Development Manager at Kentek Corporation. David has been working in this space for over 13 years, joined Kentek in 2021 and had spent the previous 9 years with another laser safety solutions provider. He's currently responsible for all of the markets and sectors outside the US, Canada and Mexico. He has worked and consulted in many sectors, including science and research, industry and medical, and of course knows a lot about things like containment and controls, product classification, and compliance and training. As many of you I'm sure will know and testify, David's a very approachable chap and well-versed in international standards and norms. So welcome, David, and thanks to Kentek for partnering with us on this project today. Their support is very welcome. Next, we have Rex Alexander, President and Principal Engineer at the Handheld Laser Institute. Rex graduated from the Ohio State University with a bachelor's and master's in welding engineering back in 2016 and has spent most of his career developing laser welding, cladding, cutting and additive manufacturing processes for the aerospace industry. His first introduction to handheld laser welding was in 2020 while working as a senior welding engineer on SpaceX's Starship program. And what started as, I understand, a personal curiosity and side project quickly grew to be an industry-leading handheld laser welding program used to manufacture the world's largest and most powerful space launch vehicle. Rex is obviously very passionate about advancing the industrial adoption of handheld laser welding and currently sits on multiple AWS subcommittees. And last but certainly not least, I'd like to introduce David Werber, who is the Manager, Product Design, Compliance and Senior Electrical Engineer at Miller Electric. Miller Electric Manufacturing Company is an ITW welding products company, and David has over 40 years of experience in electrical engineering and design compliance from 3 major companies, producing electronic chemical analysis equipment, electric motor drives, and arc and laser welding equipment. David is a certified product safety engineer and a member of the Institute of Electrical and Electronic Engineers Product Safety Engineering Society. He's currently the chair on many standards bodies, including the International Institute of Welding Commission 8, Health, Safety and Environment, the American Welding Society Safety and Health Committee, the International Electro-Technical Commission TC26 and the Electric Welding Committee. Apologies, that's a lot of organizations. And alongside this, he's a member of multiple NEMA, European Welding Association, NFPA and UL committees. It's quite a CV. So thank you to all 3 chaps for joining us today. A quick bit of housekeeping before we get going. These online panel discussions are designed to be useful and interactive. So if you are watching this live, we would welcome any questions from you too. So please submit them at the bottom of your screens and we'll do our very best to tackle them across, I hope, what will be a full and lively discussion. Right, without further ado, let us start. I wanted to kick off with quite a sort of general, I suppose, point, which is about major misconceptions. What are they when people are trying to deal with the safety of handheld lasers, and what's unique about those and perhaps don't come up with other kinds of light sources? David L., I will start with you.
Yeah, the interesting thing is the general move in laser safety over the last few years is to and I affectionately call it the put it in the box school of laser safety. So wherever you can contain the beam, lock it in behind interlocks, lock it in behind containment, and classify the system as low as possible. So the ALARP approach to safety. The problem you have with handheld laser safety is it is literally held in somebody's hand. It can't be anything else. And so as a result, it can never be anything other than a class 4 laser. So
Mm.
that's the biggest single challenge. And it can only ever be used as a class 4 laser. And you've got a really powerful, instead of having a few watts in a university laboratory, you've got a few kilowatts in your hand. And it's designed to, material process. It's designed to melt material, and it's literally like a gun. It's almost like Star Wars. So that's the biggest single challenge from us. There's no way we can mitigate the risks. The risks come in training, risk assessment, and local rules.
Okay. And do you think people generally, when they are kind of using this equipment for the first time, would you characterize their kind of engagement with it as being a bit nervous to start with? Do people understand the power of what they're being asked to do?
I'm not sure they do, and I think it's because the handheld laser welding generation has taken lasers into what has been hitherto a market they've never known about. So up to now, it'd be high value, high precision manufacturing. Now with handheld laser welders, they're being found in job shops and man pass shops where they've got this thing. And don't get me wrong, I mean, traditional welders have got a great deal of experience around the hazards and dangers around conventional welding. And I don't know the right word. Complacency doesn't quite sum it up, but they believe that if they can handle the challenges, the hazard and the risk challenges with conventional welding, then laser welding's just on top of that. But it's a whole new set of unexpected risks and hazards that they've just not been used to and not ready for.
Okay.
Yeah, I think, building on that, I think there's all sorts of the spectrum in terms of how people are approaching handheld laser safety. When I first started doing handheld laser welding, as David mentioned, the typical approach is to keep things in a box. And so all my background in laser processing was having it in a box with a robot or a CNC machine. And I got my first handheld laser, and all my friends told me, "Oh, this is the worst idea ever. You're gonna go blind." And at the beginning, I agreed with them. I was like, "Yeah, this is terrifying." And as I became more familiar with operating the equipment and the proper PPE and procedures, I became less worried about it. Now, the flip side of that is I also know a lot of people that I've met in the past year or so that have no idea about laser safety with handheld laser welding systems because there's not very much information out there. So I think there's really two sides of that coin. You get people who are very, very cautious about it, then you get people who are very, very flippant and don't understand it at all because of the lack of knowledge.
Yeah, I guess too much knowledge is a good thing sometimes. In EG, you might approach it with too much kind of fear, but equally not going in with enough understanding is equally bad. David W., what thoughts on?
Yeah, so another misconception that we see in the field is that most people using the equipment are not even aware of the intense power that these lasers need to emit, obviously for melting metal, for welding or cleaning. Another misconception, though, too, that we see is that they don't think the laser beam is hazardous because it's invisible. And what they do see is the guide laser, for example, right? Just like your laser pointer. And that gives them the misconception that it's not a dangerous or hazardous operation to perform. So we see that quite a bit as well.
Okay. I mean, in terms of the difference, you've articulated how different that is. Um, where do you think the traditional welding companies and users are finding knowledge gaps? Where is their kind of dark spots in terms of understanding how to approach dealing with these pieces of equipment safely? David W., I'll go back to you first on that one.
Sure. Yeah. So what we're seeing is, the speed and the massive proliferation of the use of these products. That led to a lag in adequate safety information and training for the users. And also, due to the fact that people that are using this, it was mentioned earlier, using the standard arc welding processes, they're already aware of, the necessary precautions, things like electrical precautions, fumes and gases, fire explosion, burns, etc. But they tend to believe that there are not additional laser beam hazards, and that's where the real training needs to come into play. And the things that we've created so far in industry to help support that, the guidance documents. I can talk a little bit more specifically about that later, but
Okay.
that's what we're seeing.
Okay. Let me think. I mean, in terms of the practical kind of reality of dealing with this, I mean, the proliferation is a well understood kind of symptom of the technology advancements, I suppose. David L., what do you kind of characterize in terms of the processes that companies get to even get to the point where they understand that this is what they need and what they need to put in place to kind of deal with this safely?
It depends. If the company is, fall in the side of a more safe company, if that's the right way to put it, then they will typically do a little bit of research before they actually even purchase the device. However, there's back to the comment that handheld laser welding's taken what was traditionally a high precision, high value research and development type product into the general fabrication market. They see it at a show, they buy it, and then worry about it after. Because to them, they see the word welding and they go, we know welding, and that's all the rest of it. To them, it's just that, laser is a different, you've got TIG and you've got MIG, and now you've got laser as well. And so therefore it's treated a similar way. But in actual fact, they don't. And that itself is certainly from the EU side of the equation is a bit of a minefield. So as soon as you have one of those devices, any sort of hazardous optical radiation source in your establishment, you have got a lot of criteria you must comply with before you should, in theory, use it safely. Whereas they are more gung ho and go straight in and, oh, look what I can do with this now, and then worry about the safety implications after. And it mostly comes down to training and awareness,
Yeah.
but then also the issue of the actual kit that they need, the PPE, the correct stuff. But it always starts off with training.
Okay. I've got a supplementary, but I go to Rex first, if I may, just to answer that question as well. Where are the most typical knowledge gaps here?
I think, to be honest with you, there's probably knowledge gaps everywhere. And it's not for the lack of some of that information being out there, but I think it's more so about the publicity or the availability of that knowledge. Here in the States, at least, we've got ANSI 136.1 and OSHA guidelines, and some states also have requirements for laser safety. But I had a conversation with someone just last week where I told them they were doing things horribly wrong and I needed to leave because it wasn't safe to be there and I couldn't be seen with them. And they told me, well, what law am I breaking? What am I going to be fined? I was like, that's not the point, right? A lot of these standards are still being developed for handheld laser, but there are standards for class 4 lasers. And then I had to go look up the OSHA guidelines here in the United States and send them a table of all the things that were needed for class 4 laser operations. So, it's not that the information isn't out there. I think it's just that the information isn't well shared or isn't easily accessible, and I think it falls not only on the manufacturers and the resellers or distributors, but it also falls on the end users themselves. So I think we're all responsible for trying to find that information. Unfortunately, it's just not easy to get at right now.
I understand. And you mentioned end users, and my actual kind of question based on some of your answers from just now is, are you finding that these are the same people who have a previous laser experience? I'm talking about the operators here, or are they generally in organizations bringing new people in who perhaps have no context with laser equipment at all to start with? Rex, as
Yeah,
I'm on, yeah.
it's always at least the more problematic places I've been to. It's always the people who have no prior experience with lasers because they have zero understanding of the hazards that are associated with it.
Okay, David, I can see you, or David Elliott.
Yeah, no, absolutely. It's generally the first time they've ever touched or saw or been close to a laser. And that's part of the problem. There's a scaremongering, a bit like Rex said earlier, where they were like, they fall into two camps. You're going to go blind if you use that. And then and they're typically, I would always love people like that because we can always educate them to be work safe. The problem is that the people that don't think there's a hazard, that they're the ones that are the hard ones to educate to the point. And you're right, because they can't see it, because it's an invisible, blinding thing, and in some ways we've got to blame James Bond for that, for having a laser that you can see.
Yeah.
All lasers you can see, can't you? It's generally speaking, the people that have got the problem are the ones that have literally just seen it, saw what the results are, and gone out and bought it, and not had any consideration for the ramifications and impact of the safety.
Okay.
Yeah, and
David,
I think, oh, sorry, I just
go on,
want
Rex.
to
Nick, on.
put one thought there, and I think it's about the accessibility of this information to these people who David was talking about that might never have had experience with lasers before. If you look at the traditional approach to laser safety and creating laser safety officers and sharing this laser safety information, it's typically a multi-day course type of operation where it goes very, very in depth into this is a laser, and these are the underlying physical principles behind a laser and how the laser is generated, and all sorts of details that aren't really necessary for someone to understand how to safely use a handheld laser in an industrial scenario. And so I think, Kentek, you guys have done a good job with your online laser safety trainings that you've got. You've got the full, 2-day course, and then you've also got the 30-minute course for welders. And I think part of it is how do we simplify that information for these people who have zero laser experience and only give them what they need to know to be safe without giving them all the extraneous information that's not actually useful to them.
Okay. David W.
Yeah, I think another thing that complicates the training and the safety information in general is the fact that, there are companies out there that are touting these products to say, a user with no training basically can operate this because the welding process is very simple with this and can be super efficient and easy to learn, but the safety aspect has to be covered in depth and very thorough, like Rex just mentioned with LSO training and the like, and the requirements that people have that and organizations have an LSO on staff and use an LCA at every point of use, laser controlled area. So there are all those things. And I don't know, Mark, if this is a good time, but maybe to highlight some of there's 2 documents that we've created for industry, at least through the committee work that I'm involved in. But the AWS Safety and Health Fact Sheet number 46, which if you go to aws.org, it is there for free download. And it's a very concise 3 or 4 page document, highlighting the safety aspects of the use of the handheld laser welder. And then the second document was through IIW. It is the considerations for handheld laser welding. And that's a longer document, more of like a white paper, but has a whole section on safety. And it's also available, 38-page document available for free download for anyone that wants to learn more about the processes and also the safety aspect.
Yeah, I guess
So, thank you.
The reality is companies need to go into this with their eyes open. The operators do too, but there's a kind of a balance to be struck, isn't there, between fear and kind of ignorance, really, and somewhere in the middle is a sort of sweet spot. The question then that obviously comes to mind then is regulatory context, and I appreciate we've got speakers here who are sort of on the US side, and we've obviously got some European representation. Where does the responsibility for properly educating welders on handheld laser safety practice best lie? And the question that kind of falls out of that then, depending on your answer, is do regulators need to do more to raise awareness? I'll go back to you, Rex, if I may, first on that one.
Yeah, this is a good one. I don't think it's right to put the responsibility on one single group of people or one single organization. I think we all have the responsibility, both as, regulatory bodies, manufacturers, distributors, and end users. I think everybody shares that responsibility, and that's the only way that we can truly do this safely. Now, with that being said, I think there's things that every one of those groups can do differently to make this information more accessible and more digestible. From a regulatory standpoint, it would be great if we had one single regulatory statement about handheld laser welding. The guides that David has helped put together, I think, are excellent guides. But to my point earlier, where I was, literally arguing, yelling with this guy on a on a show floor, and telling him I was going to leave because it wasn't safe. His point was, well, I'm not breaking any laws, so who's going to find me, right? And that's not the right approach, but we're going to encounter people like that out there, and without the regulatory bodies to enforce that, it's simply not going to happen. Now, on the other side of that, I've worked with manufacturers and resellers or distributors who take safety very, very safely and make sure that their customers understand laser safety. But I've also worked with distributors who have zero regard for laser safety, almost independent of what type of equipment they're selling. And so I think they also share the responsibility. And then, there's a little bit of responsibility for the end user to be at least somewhat curious about it. But if the people above them aren't doing their job, it's simply never going to happen.
Interesting. David, I'm going to hope that you're going to tell me this, that
Yeah.
experience is
Our
an isolated one, but maybe not.
Yeah, our approach is kind of upside down in a way. And when I say our, yeah, European law, definitely Britain and Europe on the whole, that in actual fact, it's the user that's responsible for the safety. And they're responsible to make sure they're working safely. And if they feel uncomfortable about that, then they need to ask. That is a little bit different from the person that goes to jail if somebody gets hurt. Okay. And generally speaking, the person that goes to jail is the director of that company. So they have a responsibility, legal responsibility to make sure their people are safe. Now, we've got a lot of additional controls, that we can't bring in things that are unsafe. You guys have worked with CE, for instance, many, many times. So, you can't import a product that is not inherently safe to start with. Now, when I say inherently safe, meets the required standard. So a class 4 laser is obviously applicable to CE, and it does go through a whole set of tests to make sure that it is what it says it is. But ultimately, it's the user that starts. But so it's not legislatively controlled in Europe, other than through a thing called the Artificial Optical Radiation Directive. So the Artificial Optical Radiation Directive, it's a very loose generic term that said if you've got a hazardous, artificial optical radiation source, you need to do something about it to keep your employees safe. And it gives guidelines, but ultimately it's down to I call it the risk appetite of the organization as to what level they need to go to make sure they're working safely. And what I mean by risk appetite, you can have two organizations that are doing exactly the same process and they approach the safety from a different perspective. One will be belt and braces and have everything completely covered, and one will be right on the minimum edge. But the one thing that is important is what I affectionately call the laser police. So these are the guys in the UK, it's the health and safety executive. In Germany, it's OSTRV. In America, OSHA, but I'm not sure exactly where their line of demarcation starts and stops. But the health and safety executive in the UK can come along and just, if they don't feel that the industry is working safely enough, in any aspect, not just lasers, in any aspects, then they can shut down that organization. And the level of fines in the UK are just beyond comprehension now. A few years back, there was a sea change in the level of fines, and these are criminal fines that you cannot buy insurance against. So the force is forcing them, and quite rightly too, for the organizations to do things properly,
Yeah.
actually, do what they can. You will always get what I call the Darwin effect, where you've got a user that goes, well, yes, I've been taught how to use it this way, and I'm not going to pay any attention to that. But ultimately, the responsibility for working safely lies with the user first and foremost.
And is there any kind of rhythm to where that culture, you described two cultures there, the sort of slightly laissez-faire and the sort of straight down the middle type. Is there any kind of typical kind of shape of why those organizations fall into those camps, or is it driven by, the executive board or just scale? Is it scale?
Mud slides downhill, Mark.
Yeah.
So it usually comes from the top. Yeah,
Okay, fair
it
enough.
usually comes from the top, and it might be because there's been a near miss with a director that's managed to avoid it, or it might even be that he's actually been prosecuted before.
Yeah.
But generally speaking, the principle is you want to look after your people. An organization's nothing without its people, so you look after people and you give them the tools and the resources and the training to make sure they're working safely. That's typically now when I say there's two camps, it wasn't so much two camps. It's more the extremes of the same
Yes,
camp.
yes, I understand. Yeah, 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 yeah.
Yeah.
No. David W., thoughts on this point?
Yeah, thoughts from me. As far as regulations go in the U.S., Rex referenced it a little bit, but there is the OSHA Technical Manual, Section 3, Chapter 6. It's laser hazards. It does cover some aspects, and it's a relatively good guide. But there again, it's not a CFR. It's not a Code of Federal Regulations. It's just a technical manual from OSHA. But as far as from our perspective, specifically back to the responsibility. It really lies with the organization putting together a couple things, with three major points, appointing an LSO or being trained as such, somebody in the organization, at least one. Second point, I guess, would be having a documented laser safety program. And then the third thing is having a laser controlled area. I mentioned it earlier, an LCA for each point of use. And, that gets really interesting too, as everyone online knows, when you get into outdoor applications, unique confined spaces, all the things that happen with welding, an LCA might be a more, difficult item to attain. So, yeah.
I've got a
I
question.
think OSHA has about the best thing available in the U.S., but that's only a guidance once again.
Okay. So the laser police that David L was talking about, are they called in because somebody's got a concern routinely? And I know it'll be different country to country and, resource level to resource level, I guess. Or is it that they can do kind of random inspections of organizations that have this kind of kit? Back to you, David L, as you raised it.
Yes, they can do random inspections at any point, and they do random inspections at any point for all of the risks and hazards that are out there. The problem we have is that as our users need educated and trained on the hazards around laser, risks and hazards around laser usage, the inspectors, the laser police, and I'm using that phrase very generally,
Yeah.
the laser police have got limited knowledge and experience of it as well. And so there's a dedicated team, the National Radiological Protection Board, the NRPB, that kind of sector that have got specialists in radiation. Now, are they going to go down and do a random inspection on a fabrication shop and a job shop that are using a laser welder? Well, they might, but the problem we have is that the sales of these things are just exploding, and there's just no way that that can be managed on an point of usage methodology. It's got to take a step back and look at something. And I hate to say it, it will take somebody getting hurt seriously before a lot of focus goes on. And I would like to think that we're ahead of the curve on this one and actually train people to make sure that we don't get in that position.
Yeah. It's a technical question, actually. Given the different applications that this equipment is being used for, would a generalist inspector, if that's such a phrase is valid, be able to spot the issues or the problems that are there? Would.
Yes. Yeah. I would like to think that, safety is safety is safety. And it's not so much what they're doing, it's how they're going about it.
Yeah.
So if they've actually produced some risk assessments and anybody, whether you know anything about lasers or not, can read those risk assessments and decide whether they've looked at all the possibilities and managed the risk accordingly, then I would like to think any health and safety inspector would be able to do that.
Okay.
Yeah, I would hope so. I think my counterpoint to that is I've worked at places in the past where I knew more about laser safety than our appointed laser safety officer. And I think that's not uncommon with customers that I go to visit. So I think, playing devil's advocate here, if someone from OSHA here in the States visited a shop and saw handheld laser welding going on, I'm willing to bet there's at least a 50-50 chance that they have no clue. Right.
Yeah.
And I think that's because of how new the technology is and how little people understand about it. And unfortunately, to your point earlier, yeah, it probably will take someone getting hurt for that to happen. I wish it wasn't that way. Um, I'll play devil's advocate a little bit more here. Um, if you are not welding aluminum or copper, handheld laser welding is actually extremely safe, much safer than you might expect. I was extremely worried about handheld laser welding when I first started using it at SpaceX. And, early on, I worked with Kentek quite closely actually at SpaceX. And so I called up Paul in the United States and I said, hey, Paul, I need someone to come give me a hazard assessment of all these places we're thinking about doing handheld laser welding, because it wasn't just in rooms, it was inside of tanks or on the outside of tanks or things that we couldn't fit inside of rooms. And they told me on the phone, they're like, well, we could just give you that report remotely. And I was like, no, no, you come here and you see everything I'm doing, and then you tell me that it'll be safe. And we did, and we got the report. It made me feel much better about everything that we were doing. Now that being said, again, I think, and I'm playing devil's advocate here. I think there's probably a happy medium in between China and our current standards here in Europe and North America, right? If everybody was going blind from handheld lasers, nobody in China could do their job, right? We've all seen the TikTok videos where if you're lucky, they're wearing flip-flops, no laser safety glasses, no gloves, nothing. And then on the flip side of it, here in the States and in Europe, we've got laser safety glasses and face shields and the whole 9 yards. Now, I say there's probably a happy medium somewhere in between there, but I'll be honest with you, I don't want to live in the happy medium. I want to live in a world where I've got full vision in both my eyeballs. And when we're preparing for industrial laser or really industrial safety incidents as a whole, we're not preparing for everyday operations. We're preparing for when two, three, four, five things go wrong all at once, and we've got our bases covered. And so while I think we are quite conservative with the way that we've approached this here in the States and in Europe, I think conservative is the right approach here.
Yeah. David W., agree with all of that?
No, I completely agree on both points. I mean, David, your points of standard safety inspectors should be able to point out and realize the issues, but they have to have some training too. I mean, another thing that we need to consider, they need to consider always is reflections, for example. And I know Rex, you just mentioned, well, if they're not welding aluminum or copper, it can be quite a bit safer. But there are those, shoot through problems, incorrect settings on the equipment where the focal point is not correct, and you're going through your workpiece, for example, for welding, and you've got other issues occurring. You've got other people, for example, in an LCA that may not be wearing the appropriate PPE, and all of those things. And another thing, is one thing we've noticed and we're concerned about, obviously, is your standard arc welder and his equipment, his or her equipment, and the operation of it, and the fact that they think that all that PPE is going to be just as adequate for handheld laser welding, of which we all know it is not. You will not get the appropriate protection, to the eyes and the skin potentially. So there is still, in agreement with you guys, but I still think maybe there's a happy medium, but I think it's a little more towards the conservative, at least from my perspective.
Okay.
Yeah, I think there's no point in living in the happy. I much
Right.
prefer being safe. Now,
Yeah, for
to that
sure.
point, I think that brings up some interesting things, and I think from a real world application standpoint, right? I think that handheld laser welding of stainless steel or copper or sorry, stainless steel or carbon steel is very, very safe. It's unlikely that you get a specular reflection. That being said, David, as you mentioned, the potential hazards for an intra-beam hazard, if you're welding, say, a corner joint, or you penetrate all the way through a groove weld, are
Mhm.
severe. You
Right.
need to be wearing proper PPE, and you need to be aware of appropriate um, welding angles or positions. I see to this point, I see a lot of people doing handheld laser welding without gloves because the heat input is just not the same as arc welding. And unfortunately, that's not a very safe thing to do. I have yet to meet in the past 5 years or so anybody who's actually had an ocular hazard from a handheld laser welding system. What I see more often than not, though, is people who are used to arc welding, and they'll take their pointer finger and their thumb and they'll pull two pieces together like they're going to tack it, and then they'll shoot through their glove. Right. So I think that is an important aspect of safety, that it is maybe just as important or more important based on frequency of injuries, is being mindful of where your body is relative to the laser. Especially so if you've got an open corner joint or you're doing a groove weld with no backing, you have the hazard for or the potential for an intrabeam hazard. And we've been talking primarily about laser welding, uh, handheld, up until this point. But I think this also brings up another really interesting area where you see a lot of these Chinese machines that are also capable of cleaning, or they're capable of cutting, which introduce, I would argue, even greater hazards than handheld laser welding. I was at SEMA, North American Auto Show, last year presenting, and I went outside in between conference halls, and there's a guy with a cleaning laser out in the open outside of the conference halls, no backstop. He had laser safety glasses, but he's cleaning horizontally at face height with a crowd of hundreds of people around him, which is absolutely terrifying and made my blood boil. But I'm sorry, I didn't have laser safety glasses in my backpack, and I wasn't about to walk up to the man that close and tell him he was wrong. Uh, and I think even more hazardous probably than the cleaning is the handheld laser cutting. With that particular application, you are intentionally creating an intrabeam hazard on the other side of the part that almost never occurs with handheld laser welding. And so there are these other processes with handheld lasers that I think are much, much more dangerous than welding itself that we haven't touched on.
Wow. I mean, it's quite extraordinary to me. It sounds slightly kind of, I don't know if you're familiar with the phrase Wild West to me in a way. And I guess coming from a European context where everything's quite regulated and, as you say, conservative, it just sounds to me slightly kind of extreme that this can be allowed to happen. So where are we on that journey of getting it right? I mean, I suppose there might be a difference in geographical perspective on this, but if kind of we're better than terrible, but somewhere short of perhaps consistency, where do you think we are? About halfway to where we should be, or is it generally almost
There's a
impossible?
process. There's a very simple process. Laser safety 101 is understand your beam and
Yeah,
then contain it.
yeah,
That's laser safety in very simple terms.
yeah,
Understand, and when I say understand how risky your beam is, what is the eye safe distance? How far away do you need to be? Is it a few meters? Is it a few miles? It could be either. And then manage the people that are potentially going to be exposed to that risk. And that's the principle. And you can apply that in any way, shape, or form with a 100 kilowatt laser, with a 1 kilowatt handheld. You manage people that are going to be exposed to that hazard. Yes, I mean, in terms of this is where the actual application, from Rex's point of view, yeah, quarter joint, a seam joint, whatever. In a way, I don't know about that, and in a way, I also don't want to know about that as well. I want to know, imagine if that beam was just fired straight at somebody, which is the worst case scenario. Even on our calculations and our risk analysis that we do, we also base, let's say, a diffused reflection. We base a diffused reflection on a reflector that's got 100% albedo. Now, there's nothing in the world that will give 100% albedo, but we base our calculations on that. So it's the worst case scenario. Now,
yeah,
is it conservative? Maybe. The other problem we've got is the standards aren't keeping up with the application. So one of the standards, for instance, it expects the containment to be good for 100 seconds. And 100 seconds is simply an eternity in welding. It's unheard of. So the
I would argue
standards need.
even
Sorry?
oh, I would argue even those standards, David, are probably inadequate.
Yeah, yeah, absolutely.
I've done my own testing trying to replicate this, and every time I've done it, it's not
Have
what
they
it says
been
it is.
over safe or under safe, Rex?
I think with some of the enclosure materials under safe for the
Okay,
handheld
okay.
laser. Yeah.
Using which methodology to measure them? The ANSI ones or the EU, the EN ones,
This
or
is more with like the ANSI side of things.
okay,
So, I mean,
yeah.
my big example here is, we've got curtains, we've got hard barriers, right? And
Hmm.
what I've experienced is with the let's say the hard barriers of the type where it's a corrugated plastic with a laminated sheet of aluminum on the
Yep.
outside.
Uh-huh.
Those are fine for a diffuse reflection, but for the love of God,
Well, how do
don't
you
hit
cut
that.
that? How do you cut that substrate to make it into the barriers? You quite often put it
Well,
on a flatbed laser
yeah,
cutter.
exactly, right. So like on that instance, do I agree with that material? I'm torn. There's certainly
Yeah.
better materials, but I would argue that from a handheld laser welding standpoint, if we're worried about intra-beam hazards, some of these materials that we might say are adequate beam stops for, say, laboratory lasers, are not entirely adequate for handheld
Mm.
laser welding.
Yeah, yeah.
Okay.
No, the one other thing it's fortunate, most of the handheld laser welding has come about because of fiber laser development. You can produce a plug top efficiency that's very high, never heard of before. You're able to deliver that beam to a point where you want to, and fiber lasers typically are a fairly tight wavelength, and then obviously the wavelength that works on the substrate. But different materials react different ways with different wavelengths and also with different spot sizes as well. And to be fair, handheld laser welding is relatively simpler to manage because the wavelength band, the spectral range is much, much tighter.
Terms of, we hear a lot about the people coming into the job market who are, there's always a skills challenge in a lot of technology companies, and this obviously presumably drifts into welding companies as well. Are people coming into the job market learning their kind of skills at colleges and universities and things? Is there any kind of exposure to this sort of technology there that you routinely see? So, and is there more people could do to acclimatize themselves to it? I'll go to you, David W, on that one, if I may.
Yeah, real quick. I mean, we work with a couple of universities up in Canada that are, that are very, very well versed and very involved in the research behind the handheld laser welding product. So they have students that, but these are just pockets of areas. But I think in general, throughout industry, throughout universities, throughout technical colleges, I don't think the coverage is very, very thorough, but there's pockets of really good areas where they are getting exposed to it. But the other part of that whole thing is the knowledge and the training, and how do we get these documents that we've already created for industry? How do we get those into the training areas, into the areas where they're educating, the new folks that are coming into the industry, so that they come in with knowledge about the safety and all other aspects of this product.
Okay. And
The
David,
other thing with handheld laser welders, they've actually de-skilled the welding process.
yeah.
Yes.
It used to take a welder, I don't know, 6 months to be good at TIG welding. And that would be good, not excellent. And
Right.
now after 20 minutes of training, I could weld aluminium. And that is kind of scary thing. Uh, how do we
Yeah,
get that training into those people?
Yeah.
yeah,
Um,
I'm
Go on, Rex. Sorry.
Yeah, I was gonna say I'm gonna play devil's advocate to that for just 1 minute here. And yes, I can teach my grandma how to laser weld aluminum. No doubt about that. I can teach my grandma how to do it on a coupon on a flat table. I think this might be one thing that's overhyped with handheld laser welding is how simple it is to operate.
Okay.
Anybody can pull the trigger, but not anybody can make a high quality weld day in, day out on existing hardware. And I'll tell you, running the Handheld Laser Institute, this was supposed to be part-time consulting for me after leaving SpaceX. I was supposed to be halfway retired right now, and I've got 3 employees, and we fly all over North America and train people everywhere. And I think it's still just the tip of the iceberg. If handheld laser welding was as simple as people say it is, I wouldn't have a business that's growing as rapidly as it is. Now, that being said, going back to the university or the technical school or trade school conversation with safety, this is something I'm very interested in because that information, for the most part, it's not out there and there's not a good way to disseminate that information. I was actually at a community college just yesterday touring with them and discussing ways to build a laser welding program and making a way to, create a curriculum that could be deployed across many schools to help educate people more simply. And I think that's one way to do it. Now, I really hate the next thing I'm going to say because I hate social media, but if you want to educate the masses, if you want to educate Joe Welder, who is sitting there on TikTok for 30 minutes during a bathroom break, um, the way to educate him about laser safety is unfortunately through a TikTok video. And I say that tongue in cheek because I'm a data-based person. I'm an engineer. I don't do advertising. I don't do videos. I don't like those kind of things. But we're talking here about all the technical sides of things, and I think the way to educate the masses is to use the methodology that the masses uses. And, maybe we need to get together and do a TikTok laser
TikTok, yeah,
safety and
well,
do something
okay,
that
I'm gonna
goes
hold.
viral. And
Yeah, no, I'm going to hold you to that. Now, look, we've had some questions come in, and I want to get to these because it's great when people kind of have got some specific things. So, a couple of questions about, well, first question I want to go to is a fairly quick one I hope to answer. Which wavelengths present the greatest reflection hazard during welding? Who would like to answer that one first? So sort of like David.
Depends on the substrate.
Okay, depends on the substrate. Okay, anything to add to that, David W or Rex? No, happy
No,
with.
no, I think there are some narrow bands that are typical, but to the point of David Lawton, I mean it depends.
It depends.
yeah,
Okay.
And you
Give you an
need to
example,
understand it.
Mark.
Sorry.
yeah,
And
I'll
the other
give,
part and the
Yeah.
other part about that is you need to understand, but you need to then uh, purchase the appropriate PPE for those wavelengths at the appropriate optical densities, and that's key.
Okay, so
yeah,
take some
agreed.
proper advice. Yeah, that
Give
seems
you
to
an
be.
Yeah, and
example, Mark. There's a laser manufacturer that are actually making a blue laser
Yeah,
because they've figured out that the absorption in certain substrates, let's say gold and copper, are 13 times higher than they would be if using an infrared laser. So instead of using a 1300 watt infrared laser, you can use a 100 watt blue laser.
yeah,
And because the absorption in the substrate is just so much higher,
yeah.
and as the knowledge base moves on, then the application moves on. But the principles from the safety point of view are exactly what David W's just said. Understand the risk and contain that radiation.
Okay.
yeah, and I want to flip this question on its head just a little bit, really
Okay,
quick,
go on. Yep,
if I may.
you may.
Um, from a practical standpoint, we're really only dealing with a very narrow band of wavelengths with handheld laser welding. They're all fiber lasers. We're dealing with, say 1070 nanometers plus or minus 10 nanometers. So there's really only one band that we're particularly worried about with these handheld lasers. But to the David's point earlier, it depends. I would argue it depends on the substrate, right? And generally speaking, stainless steel, copper, nickel-based alloys, they're about, 30 to 40% absorptive in the solid state. But copper, aluminum, we're talking 98, 99% reflective in the solid state. So reflection is not a matter of surface finish on your part. When we're talking about handheld laser welding, is more of a material property. And so instead of being worried about wavelengths and reflection, I would be worried about materials and reflection, specifically aluminum and copper.
Okay, brilliant. Thank you. Just going back to a point, I'm not sure who made it about material suitability for laser protection. Daniel has asked, shouldn't you consider the rating's power density and select the guard based on that? It's obviously quite a specific point. David L?
Yeah, yes, but there's other factors as well. So, for instance, the wavelength and also the material substrate, and then the power density as well. And generally speaking, in my experience, different materials work better for different wavelengths, if that makes sense. There's not for instance, aluminum is particularly good for small spots, but not very good for big spots. Other materials are, steel, for instance, can often be quite good. Carbon, slab graphite is very, very good, but quite expensive. So it depends. It's back to look at the application and understand what the risk, the foreseeable, the FEL as they call it in EN standards, the foreseeable exposure limit. Work that out, make sure that you've done that testing with the product that you're hoping to block it with, compare the two, and as long as one's above the other, then you're good to go for the time period that you need to test it for as well.
Okay.
You know, so there's a lot of other factors, but also just to throw another factor in here, there's one company that are producing a laser cleaner now that they've deliberately pushed the wavelength above the retinal hazard region because the eye safe distance at that wavelength is much shorter, and so this particular laser cleaner, only the user has to wear eyewear. Anybody else in that area doesn't. So they're almost taking the knowledge of wavelengths and laser safety and changing and using that product to suit the application because it suits it better. You know, I thought that was quite innovative.
Yeah. Okay. I can see you nodding, Rex. Anything more from anybody on that one? That doesn't need to be.
No, I think that's a very clever way of approaching it. I hope we see more of that in the future.
Yeah, agreed.
Yeah. Okay. And then the final question that's come in from Ken: how do you feel about ventilation fume control? Okay.
Can I throw something in here?
Yeah.
So I don't know whether you guys are aware the new ISO 11553 Part 2, which is due to be published, it's for handheld laser products. It's due to be published January, February next year. For the first time ever, it also accommodates fume and hazards created by fume, which in the past has never been covered by any laser safety standard because it's not a laser risk, it's not a laser hazard. But the new standard's taken it on board because it's created by the hazard, by the hazard application, by the laser application.
Okay.
And if I could just add quickly, from a manufacturing standpoint, and a manufacturing equipment designer standpoint, our approach is always to, deal with the fume. In other words, make the fume, exhaust the fume at the point of the source and get it out of the breathing zone, if at all possible. And that would still be the recommended practice from that perspective.
There's a company in the UK that actually have developed for a couple of medical and aesthetic laser companies an at-point extraction system. So it's literally in the handset. It's coaxial down the handset.
Okay.
Very clever.
Okay. We've got a little bit more time left, not a lot. So I just want to go to another couple of questions, if I may. One is about how welding companies choose their kit. It's a complex market. There's a lot of product out there. What advice can you give to people making those choices? What do they need to do and think about to find the right products for their needs? Rex, I'll go to you first, if I may.
Yeah, sure. So I'll tell you, here at the Handheld Laser Institute, I try to be as agnostic as I possibly can. Now, I've worked very closely with IPG over the past 5 years just because of my experience with them at SpaceX. And it's actually been very interesting to me as I've been surveying the market for the past 3 or 4 years now, trying to find something that meets my requirements in terms of safety, repeatability, reliability, and after sales support and spare parts. Those are the 4 things that I look for. Now, with that in mind, I also realize that not everybody needs a $40,000 to $50,000 laser. And often people who are looking at getting started in the world of handheld laser welding, that's cost prohibitive. And so for different types of manufacturers, perhaps there is a less expensive yet safe and reliable system at maybe half the price that for a fabricator who's doing a bunch of one-off jobs would be a great solution. But if you're, say, an aerospace company looking at buying dozens of these machines and you want them to be repeatable from one to another, well, then you probably need to spend more money. And so I think those are my big 2 points, right? And one is, what do you actually need to do with it? Are you looking at dipping your toes in it, or are you looking at beginning hardcore manufacturing and production? If you're just going to dip your toes, find something that's safe, reliable, repeatable, and hopefully has good after sales support and service, which you might not know that last one until it's too late. But safety is number one. Ideally, your system's got the nozzle interlock, ideally, it's got a an external interlock for a door. Those are pretty common across all systems on the market, but I would argue that I wouldn't touch anything that doesn't have a dual trigger. I've seen too many people jumper the nozzle safety with cheap Chinese equipment, pick up the torch with one hand, accidentally pull the trigger, and shoot themselves in the other hand while they're dragging the torch across the table. I personally will not touch anything that doesn't have two triggers. And I'm seeing more and more equipment come out on the market that does have two triggers at different price points. Uh,
Okay.
you know, yeah.
Yeah, good tips there. David W. on this one.
Yeah, I guess this one's kind of close to my heart as an equipment manufacturer and designer, but so we detailed very specifically once again in that AWS safety and health fact sheet. Rex already mentioned some of it, but a key switch to secure the equipment, make sure there's not any unauthorized operation, emergency stop button to terminate the laser emission immediately. These are all safety features I think the equipment needs to have. Connection for an external interlock, like Rex mentioned, door interlocks for LCA, for example, and then even additional features. Rex just mentioned it's a two-stage trigger, but also in addition to that, plasma detection. So if the plasma is not formed in a very short period of time, the equipment will turn the laser emission off. And then workpiece contact circuit and even optical interlock circuit in the fiber optic cable to make sure the connections are there before you even get to begin to weld. So those are just a few of the features. And once again, they're detailed in that document that we created from a guidance perspective. So I think that's a great place to start.
Okay, great.
It's a little bit easier in EU land, in CE land, because all of those criteria, with one exception, are absolutely, must-haves in order for it to be CE. The one that is the exception is the plasma detection. Now, it's interesting because I believe, although I haven't read the standard, the new 11553 Part 2 actually calls for that. And that will then get adopted into CE. So in order to have CE in the future, you will have all of those things that you must have: key switch, interlock, grounding on the head. We'll also have to have plasma detection as well.
Okay.
That's great to hear.
Daniel's come back actually with another question, and he said there's a big Chinese market, which I'm sure we're aware of. People tend to be a bit nervous of it. Are there any recommendations to which ones might be better if people are really insistent on the cheapest product in the market? David, you're going to have a view on this. David W, maybe, but David,
I can't speak on this one. I just try.
Right.
I know how to switch them off.
Okay.
That's all I can say.
Maybe that's the answer. Maybe we should just stop it there. So approach with caution is probably true of all photonics technologies, really, with the Chinese market. But anything more constructive to it?
I would add one comment there. I think we've seen a lot of cheap or dangerous equipment coming out of China, but if there's anything I took away from FabTech last year, it's that uh, you know, the Chinese are not stupid.
No.
Okay. They're very, very intelligent. They're very, very good at what they do. A lot of the innovation that I'm seeing in the world of handheld laser welding is coming out of China and not necessarily out of Europe or North America. That being said, there's a growing number of people in China who are aware of our safety requirements and are beginning to implement them into systems at lower price points. So don't be fooled. I mean, I would say probably 95% of the stuff that's less than $10,000 probably isn't safe, but I'll be honest with you, I found a system a month or two ago that I believe actually meets all of the safety requirements I look for less than $10,000. Now, is it going to perform long term the same as something that's maybe 30, 40, $50,000? Probably not. But again, if you're looking at dipping your feet into the water of handheld laser welding, I think there are lower price options for people to try it out while still remaining safe. And I think we'll continue to see the safety trickle down.
Okay, that's fair point. Okay,
and real quick, if I could just add, I mean, I would just say, get all the safety features you require, and then just make sure you're following the precautions. I mean, that's the key to all of this, and regardless of what equipment you're using, but you need to have it be safe for you.
Yeah, absolutely. Okay, we're nearly out of time, but I do want to finish on with the final question, which is always my favorite one, the crystal ball moment. What is going to happen? You've talked about a nasty injury. We don't want any of those, but what sort of trends do you see in either the laser market, handheld laser market, or indeed the regulatory framework? You know, do you see something coming up that's going to be significantly impacting safety protocols in the near future? So just briefly, if I could go to you all, David W., I'll start with you.
Sure. Yeah, I am pushing right now, and with whatever influence I can do with the committee work that I'm involved in, but really trying to push for putting some requirements and making those OSHA, for example, in the U.S. Regulations more specific and pointing to those guidance documents we have, and then the IEC and the ISO standards around the world to be able to make sure that we're providing the best products with the best safety features, but also the biggest push still needs to be in education and training, and how do we disseminate that information?
Okay, Rex, I'll come to you next.
Yeah, I think I generally agree with David's last comment there, where you know maybe we don't have those regulations, explicitly in place at this point in time, and it's probably not something that'll happen in the near future. But I would 100% agree that the most important thing that we need to do right now, in the near term, is get that knowledge and information out there. And I think that's what will make the biggest difference. I think, unfortunately, David, we're going to have to make a TikTok to teach people about handheld laser safety. That will change things faster than regulation.
Absolutely. I'm so holding you to that. We will talk about this offline. Right, David L., you answer the question as well.
What's the future bring? Higher and higher power levels, whether they're required or not, is another question. That brings a whole set of risks and hazards that will come along with it. I would like to think that the standards and norms, certainly for the EU, will catch up and be written to the point where at least there is a benchmark for what we must do as opposed to what we should do. And I think there will be a point where it will become standard practice. The penetration of laser welding, whether it's handheld or not, is it's enormous. Everything that who knows what the future will bring. I would like to think that our products will keep up to speed with the development, and we're trying to keep ahead of that wave. The challenge we've got at the moment is how do we declare that in terms of standardization, because the standards are still too slow to keep up.
Okay, all right. That's a terrific kind of wrap up. Well, look, I've really enjoyed that. It's been fascinating, and we've had some really good questions. So thank you for everybody for contributing. Unfortunately, we have run out of time now. So this online panel discussion will remain accessible on the Electro-Optics website. That's electroopticsnospace.com, and it will eventually turn up on our YouTube channel. We'll also create an online article about this. So please spread the word among colleagues if you've enjoyed the discussion and found it useful. All that remains for me to do is to thank our three speakers and the Europa Science production team working away hard in the background. And of course, thanks again to Kentek for helping us stage this today. And thank you to everyone out there who's taken the time to watch this online panel discussion. Please keep an eye out for details about future sessions. It's always a big time commitment to kind of give to these sorts of things, both from our panelists and for everybody watching. So I hope you found it useful. We really appreciate your focus and support. And we hope to see you again at one of these next time. So thank you and enjoy the rest of your day. Thanks again. Goodbye.
Thank you.
Thank you all.